Here we consider multiplication with Napier's Chessboard Abacus, and we're going to start with a single digit times a single digit. So let's do 8 times 2. In order to do this multiplication, I need to put another counter where this row and this column intersect. So that'll be right here. And then we slide diagonally down to the left, and I see that the answer to 2 times 8 is 16. Now we don't actually need these circles off to the side. I use those just for reference. I have another chessboard abacus that I've created. You'll notice it doesn't have the circles on it. And if I wanted to do 2 times 8, I would just put the counter here where the 2 and the 8 intersect, slide, and I get the answer of 16. So the next example we will do is 8 times 5. And so let's represent the 8 here. And this is 5. So one of the things you need to do with this calculating device is you need to rewrite your numbers from ordinary numbers to location numbers. I don't have a 5 on my chart. I need to create it by writing it as 4 plus 1. So again, we're going to place counters at the intersections of these numbers that have been marked. So along the 8 row and the 1 column and the 4 column, and then we slide diagonally. Now in this case, I'm going to have 2 parts to my answer, and in order to get the result, what I do is add. So we have a 32 and an 8. If we combine those, we get 40, and that is in fact the result of 8 times 5. We get 40. If you want to work with larger numbers, you can make this abacus as large as you would like it to be. So here's another one that I've made, and along the bottom it goes all the way up to 2048, and all you're doing is just doubling the numbers. Doubling the numbers all the way down. So for our next example, let's do 10 times 9. So let's represent a 9, 8 plus 1, and a 10, 8 plus 2. And then we will mark off the intersections of those rows and columns. And again, we're going to do those diagonal slides. And it doesn't matter what order you do the sliding in. Like I could have moved this one second instead of this one. They're all going to end up where they need to be. The tricky part of this is that you may have quite a bit of addition to do, but the point of this calculating device of Napier is that you don't need to know your multiplication facts. It takes multiplication and it turns it into addition, and in that way it is simplifying the calculation. So here we have, let's see, 64 plus 16, which is 80, plus 8 plus 2, which is 10. So this is 80 plus 10, which is 90 along this bottom row. And that is, in fact, 10 times 9. We get 90. So let's do another example. Let's do 6 times 12. One of the things I haven't demonstrated yet is regrouping. Sometimes you need to do some carrying. And in a previous video where I introduced the board, I talked a little bit about carrying. So 6 times 12. Let's put the 6 here and the 12 here. This could be flip-flopped, of course. We could make the 12 on this side and the 6 on this side. It doesn't matter. It's symmetrical. So we're going to have coins here. And we're going to go ahead and start sliding diagonally. When I slide this one, it's going to wind up on top of another one. So I'm going to get 2 pennies in the 16 spot. Well, 2 groups of 16 is a 32, so we're going to make an exchange. I'm going to pull off the 2 16s and put one in the 32. But there was already one there. So we've now got 2 groups of 32, which we're going to exchange for a 64 because 2 times 32 is 64. And again, you don't need to know your multiplication fact. You just know that if there's 2 in one spot, it becomes 1 in the spot just to the left. So let's see what we've got. We've got a 64 plus an 8, that's 72. And in fact, that is the answer to 12 times 6. 64 plus 8, 72.